All right, today we're going to do the semester one review. This is based not entirely off of your feedback on the self-assessment, because when I went through the self-assessment, there were very few areas that anyone in the class said they wanted to know. And obviously I want to do the whole class period today as a review, so I'm going to hit those items, and I made sure I hit those items on there, and I'm going to go through this when we've got just a few minutes left in the class. But I also wanted to make sure that we go over almost everything. So first of all, I want to make sure everyone understands the semester exam is going to be right down here when we take the exam, and it will be a middle exam, and it's going to show up right down here. It is going to be over everything we've done this semester, the entire course. Every ICANN is included, chapters 1 through 4, basically. All the information that we learned in those chapters are going to be part of what's covered in the semester exam. Any tests that we got on the semester exam is going to be included. So I'm going to kind of go through, I cut out some of the slides, I changed some of the slides, go through the whole thing. We started out with the fact that we needed to understand what the difference was between hardware and software. And chapter 1, if you remember, was an overview of all the parts and all the things in a PC. Chapter 2 went into the software, and then chapter 3 was on power and form factors, and chapter 4 was on motherboards and CPU. And that's what we're going to kind of make sure we go over today. So remember that hardware is the physical components of a computer, whereas software are those pieces of data and instruction that tells the hardware how to accomplish or what kind of tasks we want to accomplish. Software uses hardware for input, output, processing, data, and storage, and everything in a computer is stored in a series of bits, zeros and ones, and we talked in chapter 4 about how binary numbers came to be, and there's all based on really only 2 digits, 0 and 1 there. So we know that in a computer, the basic hardware is the tower itself, or the computer itself. We have primary input and output devices. Primary input is keyboard and mouse. Primary output is the monitor and printer. In the computer, the primary parts, we have a processor, a CPU that uses RAM as its temporary but primary storage, and permanent storage usually through a hard drive or some other devices as well while it's doing that processing. We've got hardware used for input and output. We've got all kinds of hardware inside the computer case. We've got, subject of chapter 4, our motherboard, and on there is a chipset, and mounted on there is the CPU. Connected to it, we have storage devices, and then a whole myriad of components, whether they're integrated as part of the motherboard or expansion card items that expand the uses and capabilities of the motherboard on there. So we've got interface cards, and we've got an electrical system, and I'm not going to talk too much on those two, especially electrical systems, since we're going to hit that in chapter 3. Hardware provides us a way to get data into the computer and get information back out of the computer as programs are running. They all have to give us some method to communicate with the CPU, where the majority of all processing takes place. And software is those data's instruction that allows us to control it. We need electricity to power our computer, and every device attached to or part of the computer receives power in some way. Input-output devices, I already said, keyboard and mouse, and output is the monitor and the printer. We know that on the keyboard we've got PS2, which is the round one. We know that the keyboard is purple and the mouse is green. And we know that USB, there's no color associated with it whatsoever, but we've got also USB connectors as well on there. We've got a number of things on the back. We've got our power supply, we've got our integrated components, so we've got our expansion cards, and we talked about in chapter 1 how to basically set up a computer and those things that are required to set it up. And again, those are the ways we connect the output devices, the monitor and the printer usually are through a monitor cable of some sort. That's a VGA one, and we talked about VGA and DVI and HDMI. Different ways we can connect up our monitors, and really printers anymore are either network printers or USB printers anymore. Inside the computer, we got our motherboard, which is responsible for connecting the CPU to all of the components. The primary thing a CPU talks with is memory. It's this primary storage device. It's where it stores data and instructions as it's processing it. And then we've got really floppy drives going away. We've got hard drive, CD-ROM, flash storage devices that are secondary storage for the CPU, but are permanent storage. We've got our power supply and different power cables that are part of Chapter 3. We'll talk about that in a little bit. And we've got different ways to connect things up inside our computer. When we're looking at a computer, we know now the basic parts of the motherboard, or actually more advanced parts of the motherboard, and we'll be able to identify all those things. But when we're looking at it, we should also be able to identify this is a power supply, this is my motherboard, here's where my CPU is. And we also know that the air flows out through the power supply, and that we should have some kind of a steady flow through our PC in order to have good cooling inside our PC as well. So we already said this, motherboard's largest, most important part of the computer. It is what allows everything to talk to the CPU, and everything is connected to the motherboard in some way, shape, or form, and allowing it to communicate with the CPU. On the motherboard, we have our chipset, which controls the flow of data to and from the CPU. We also have our RAM and cache memory, which we know is on the CPU now that we're at that part. That really is our primary storage for the CPU. We know we've got north and south bridge that has the flow of data to and from the CPU, and we know we've got a power system on there as well. When we look at a motherboard, in the beginning we were just concerned about external components, memory, CPU, integrated components, and then external components. Now we're at the point where, yes, it's Chapter 1, but it's also Chapter 4. What's this? What's this? What's this? Oh, it's got 3 PCI Xe. That one's probably a 16, maybe a 16, probably an 8. That's a PCI X1, and we've got some standard PCI slots there as well. We should be able to easily identify those. We should be able to identify that this is an LGA socket on there. And what manufacturer most likely made this one. We know that this one's for an Intel CPU from where we're at now. We should be able to identify what the integrated components are off the back of the motherboard. And this is just a nice blow up of that. We know what connects on the back as far as our there we go. As far as our soundboard on there, where do we hook up the speakers? We know that's always green, the mic is always pink, the line in is always blue. Those are some of the things that you might see on the exam as well. Also, what do USB ports look like? What do RJ45 or NIC ports look like? I know a couple people got that wrong on Chapter 1 when I asked how many network cards are on this computer, and the answer in this case would be 2. We need to be able to identify what those parts are on the back. So one of the things everybody said they didn't understand was, what is the function of the motherboard chipset? So the function of the motherboard chipset is to control the flow of data and instructions from the CPU to all the other parts of the computer. Okay? And if it's on the north bridge or the north chipset, only thing that's on there again is RAM and video, and everything else is on the south bridge or south chipset, okay? But it's what controls the flow of data and instructions. So it talked about, when we got to Chapter 4, that one of the most important things you can look at on your motherboard is the chipset, and knowing that you've got a good chipset on the motherboard, and it's going to be able to help support the CPU and provide the kind of data flow and the throughput that you want for the computer that you've built, okay? So CPU is the chip, obviously, on the motherboard. The chipset is the microchips on the motherboard that control the flow of data instructions to and from the CPU. When we look at the CPU, one of the things that, by the way, we didn't get in Chapter 4 that I forgot to talk about was cooling. So we're going to talk about CPU cooling when we get back. Normally that's part of the final exam, so if I accidentally miss a question on there, I'll make sure that we give credit for that. Again, north and south chipset, when we talk about that, we said in class, the biggest heatsink is going to be the north chip, and the smaller one, if it doesn't have a heatsink at all, is the south bridge chipset on there. So any more on newer ones, they both have heatsinks on there. As far as storage, we know that we've got both temporary and permanent, and we also got primary and secondary. RAM and cache, which actually is a form of RAM, we know, is temporary. Did I grab her pen? Temporary, because I'm not writing. And also primary. And permanent would be like our hard disk drive. And that's secondary, okay? It's secondary because CPU doesn't write to it, okay? Memory controller moves information from memory to the hard drive, but the CPU doesn't talk directly to the hard drive. That's why it's considered secondary, okay? So we've got different ways to store things, and the idea there is that memory is readily available to the CPU, whereas those secondary storage devices are not readily available to the storage or to the CPU. Primary storage is RAM or cache. It's where information is stored while processing is taking place, but it is volatile, which means that information there is lost whenever the computer is turned off. We talked a little bit about why, because of this, restarting your computer can also kind of refresh things and make it run better because it returns all the storage back to the CPU. So we've got some different kinds of RAM. Chapter 5 is all about RAM, but we know we've got all kinds of RAM available to us. And in general, we've talked in the motherboard section about DDR3 and DDR4 RAM. We also know that there's cache on the CPU, and that's part of Chapter 4, that we know what L1, L2, and L3 cache is. It's all also primary storage for the CPU, and that cache is primary for the CPU, and it's really important, and it's what really helps determine the speed of a CPU. Secondary storage is where data instructions are permanently stored. Things like CDs, hard drives, flash drives, things like that can't be processed by the CPU until it's copied to primary storage or RAM, which is why it's important that wherever it's stored also be fast, because it has to be pulled off of here, taken to there before the CPU even talks to it. So if we've got a really slow hard drive and a really fast CPU, we're going to feel like we have a really slow computer. Secondary storage devices include the hard drive. There's different ways to connect it up. We've learned this both here and in motherboards. We've got older PATA connection, and then we've got the newer SATA connection, which is much faster, and we know how many connections. We can find where those connectors are on a motherboard and identify how many SATA connectors are. And we know there's SATA 1, 2, and 3, and everything anymore is either SATA 2 or SATA 3, and most likely SATA 3 on our motherboards today. Last thing is, all those secondary storage devices, like everything else, require power, but some of these require a separate power connector, or most of them require a separate power connector for any of those secondary storage devices, and we know that those are all 12-volt connectors. So the motherboard, all the circuits and all the data goes through the motherboard through the system buses, okay, and those system buses are what transport it, and the size or width of the bus, and that's when we talked about 32-bit and 64-bit operating systems, and the operating system and how wide the bus is determines the size of the packets that get sent around. We also know that the system clock is what sets the speed and syncs up all those things that go around the bus on the motherboard, and that's determined by the speed of the memory that we've got installed inside our computer. All those buses terminate at the CPU socket. This is the bottom of an older CPU socket, but you can see that all those wires terminate at the bottom of the CPU socket. And this is a older, but it's still a decent picture of the actual system clock that sets the speed on a motherboard. We also have expansion card slots. We'll talk more about that when we get to Chapter 4 section, but we should obviously know how to identify the different kinds of expansion card slots on our motherboard. Everything that's required to access those are part of the card itself, but the ability to use it is based largely, and we're going to talk about that in a little bit, on drivers, and that was one of the things that you all wanted to talk about. Just because the technology is on the card, if the drivers don't exist for the current version of the operating system or the current width of the bus, so it's going to be 32-bit or 64-bit drivers based on whatever operating system is installed on the PC in question. And these pictures just really show how easy it is to install those, and we know where those are on the bus now as well. Then we got really to Chapter 3 and talked about the electrical system. It converts 110 volt AC power from our wall outlet, which is alternating current. If we remember, it alternates at 60 hertz or 60 cycles per second. And our electrical system converts that down to direct current, and the currents or the voltages on there are 3.35 and 12 volts. We also know that part of that electrical system provides cooling to keep us below that terminal temperature of 185 degrees Fahrenheit, the temperature at which electrical components fail. So this is just a picture of a power supply with the available connectors, and in Chapter 3 we talked about the different connectors that were available. The P1 connector that goes directly onto the motherboard, as well as the other P4 connectors that go by the CPU to help power the CPU. I thought I had thrown a picture with that on there. So the next thing you guys, when we got there, and we're still in Chapter 2, asked or had less on your ICANN was, what is BIOS? So what is BIOS? So BIOS is the basic input, output, and my pen, it's doing exactly what, let me try the other one. I just restarted too. Hers is working fine. Or did I already swap? No, this is hers. Basic input-output system, okay? It's the first program, first piece of software that runs on our computer, and it's what starts our computer. It identifies all of our parts, and it passes off or determines where the operating system is, and then passes off that list of components that's on our computer to the operating system. So BIOS is software. It's a program. It's a program that's stored in CMOS ROM. The program is stored in ROM. It's stored in read-only memory, so it doesn't go away. But the things that we change in BIOS are stored in RAM. The information is stored in RAM. The program is stored in ROM. So BIOS exists on a read-only chip. And it's referred to as system BIOS, startup BIOS, sometimes CMOS BIOS, but it's the basic input-output system that starts up and configures our computer when we push the power. Okay. So that was one of the questions. What is ROM BIOS? BIOS is the program that's stored in ROM and read-only memory, so it does not go away. This is a picture of a ROM BIOS chip where the program is stored and hard-coded onto that chip. Okay, so very little memory. Memory's stored in RAM, and that is held on there by that little coin-sized battery that's on the motherboard. So it's still RAM. It can still go away if we pull the battery out of our motherboard. If we pull that battery out, we are going to lose the configuration data that's held in RAM. That's the only thing that battery is there for, is to hold that. So it's a very small amount of memory. It holds our configuration setup information that we put in there, including the current date and time, all the hard drive, floppy drive information, port configuration, and most importantly, where to look for the operating system when the computer starts. Okay. What is CMOS RAM for? One of the other ICANNs that You guys said, or some people said, they didn't understand what it was. So what is CMOS RAM? Okay, so CMOS RAM is just the location, the storage location my pen is working terrible. What could be running in the background that's doing this? It wasn't doing this the other day either. The storage location of the information I don't even understand. What could be running in the background that's doing it? That we set up in BIOS, okay? So it's just the location where we save boot order, time of date, whether we want the system to auto start, whether we want it to auto start at a specific time, do we want the different devices turned on or turned off. That's where anything that we change in BIOS is stored in CMOS RAM. And so it's volatile, it can go away if we pull the CMOS battery, but that's what it's for, okay? When we start our computer, the startup BIOS runs the power on self-test, and as it's going through there, checking through our system, that's where we said where we might immediately hear a beeping sound if we're missing RAM, or we have the wrong kind of RAM. We may get no indication, but we talked about those BIOS beep codes that we could get, and we have a list of those posted on our Moodle site of what possible BIOS beep codes are. After it does that, it looks in the CMOS RAM for where we said the operating system would be. And after it figures that out, it goes and hands off the configuration to the operating system. Operating system loads, and then we eventually see our startup GUI on the way, okay? So when it does the power on self-test, we know it checks the power first, and then runs the full post and checks through everything else, checks RAM, tests for battery failure, and then eventually looks for the master boot record on some bootable device on that boot order, and if it finds it, it'll try to load some bootable partition. So this is one of the ICANNs. How does the OS use that BIOS information? So the BIOS stores information on the basic configuration and hardware components it found during the power on self-test. The BIOS, or the operating system, then uses that as a startup configuration to decide what drivers then need to be loaded, because once BIOS has said, you have this list of components in this computer, now the operating system has to make all those components work. It does that by either using BIOS drivers or its own drivers in the operating system, and we know the operating system drivers are more efficient and faster than BIOS drivers. So BIOS basically first looks in the CMOS chip, says where's the operating system, tries to load from that location, and then eventually hands off control back over to it, okay? Operating system itself manages hardware, runs application, provides our interface, which we know is called a GUI, or a graphical user interface, to us to allow us to run our programs, to store, manipulate, and retrieve our files. We talked about the different operating systems that have been out there and the evolution of Windows, and this is just Windows user systems. This doesn't even include all the ones that we've had since I've been in computers of the server versions. Mac OS has a whole bunch of distributions just like Windows, and they're on OS X now. And we looked at during the course a whole bunch of different Linux distributions, of which we looked at Ubuntu, we looked at Linux Mint, we looked at a couple different ones that are available there. So when the operating system loads, it loads device drivers. What are device drivers? So device drivers are, simply put, they're just programs and I'm not going to be able to do this. Let's see if I can do it with my pen. Pen's working fine. What is going on? Something else get plugged in or something? It's worked fine last time I used it. I just wonder if there's something's gotten pulled funny. It's not catching it at all. I'm not going to be able to write then. At least not for a little bit. Let's see. So, device driver is a small program that makes hardware work. Without the device driver, and that's what is loading when we see the Windows icon kind of spinning around or whatever it does in the current version that we're looking at, it's loading device drivers. And device drivers have to be specific for the operating system and the bus width, okay? So if you have Windows 10 64-bit, which all the our juniors and seniors have now, and the sophomore and freshmen are getting, they've got Windows 10 64-bit, and the freshmen and sophomores still have Win, or most of them have Win 10 32-bit. Those require completely different drivers for a 32-bit operating system versus a 64. And there are hardware manufacturers that didn't make 64-bit drivers, which means you can't go from here to here and have those things work. And we have that case with some of our TV cards. They just don't work with 64-bit. They work fine with 32. So device drivers are simply small programs that we have to get. Sometimes they load automatically with Windows because Microsoft already found them and load them, but they're programs that are loaded by the operating system to make hardware work. So they're stored somewhere on the hard drive or with the operating system. Sometimes they're installed when the operating system is installed. Sometimes we have to go and find them, and they're usually written for a particular OS. Sometimes, if it's the same bus width, it'll work for the next OS as well. We have several items that only have Windows 7 drivers, but they worked fine on Windows 10. Or Windows Vista drivers that worked on 10, but you're not going to find a 32-bit driver that works on a 64-bit. It just doesn't happen. So, operating system manages hardware through those device drivers, whether they're device drivers that are managed by the operating system itself or whether they're run through BIOS, but there has to be some device driver to work for the operating system to access certain pieces of hardware. Sometimes they come on a CD-ROM, they used to come on a floppy drive, and I said in class I always recommend downloading the current one. So if we need drivers and we've installed something, even if it automatically installed, the first place I'm going to look is the website of the manufacturer, okay? If you Google drivers, you're going to find a lot of scam sites out there, and they're great sites if you want to go find a virus for your computer. Go to the manufacturer's website only, okay? So I would always recommend the manufacturer's website, and then the Windows website. So tell Microsoft to go out and find the current driver, and then lastly the CD that came with the piece of hardware, in that order. So I'm going to manufacturer websites primary, Windows using the Windows Update feature is secondary, and then the CD that came with it after that, as I'm trying to find the current or the best driver for a particular piece of software. And realize that, and we showed this in class, that you can get new drivers coming out all the time, particularly for video cards and high-end video cards. As new games come out, they'll update the drivers for that video card so that it optimizes it for that game that just came out. So you'll see video cards get updated all the time, but you're not going to see an update for your DVD player probably at all. I already mentioned this, there's 32 and 64-bit drivers, and you have to make sure it's good for the operating system that you have, and be careful on that whenever you buy a piece of hardware that you've got the drivers available for what you're looking for, and you can get them on the manufacturer's website. Next, we're in Chapter 3, we're talking about form factors and how it describes the general size, shape, and makeup of any hardware component. And form factors are really important on the motherboard, the power supply, as well as the CPU and the memory. Those things have to match in order for us to make sure the computer that we're working on works when we're done. Matching the form factors assures the motherboard fits the case, the power supply is the right voltages and hooks into the motherboard, that the holes in the motherboard fit in the case, that it screws in, and then when we get to the CPU, we know that the CPU form factor or the socket has to match that on the motherboard. And it's not talking just physically, it also has to work and be designed for that as well, because we know there are lots of speeds of DDR4 memory, but your motherboard may only take 2 of those, and if you buy the wrong one, it's just not going to work. So form factors make sure that we know the parts that are going to fit together in our computer. We know there's a bunch of different form factors. We talk about ATX mainly in this class because it's the primary form factor developed back in 1995. And when we say ATX, we know we're talking about mini, we're talking about micro, we're talking about full size. We're just talking when we talk ATX, we know all the ATX components will go together. Okay. One of the definitions of ATX is that the power supply always blows air out of the case. We also know on ATX that there's a basic design of integrated components, CPU, memory, with all the expansion stuff being off to the side, and whether it's micro, mini, full side, extended, really it's extending out here and like this as they get bigger and bigger, but the general size and shape and design of it remains the same. Power on those, use a P1 power connector as well as whatever the power connector is for the particular CPU on your motherboard. And then we got into power and alternating direct current. We know that alternating current cycles at 60 hertz or 60 cycles per second. Direct current doesn't cycle at all. The power supply is a transformer rectifier. It rectifies it from alternating to direct and then transforms it down to those lower power settings that we need. We talked in class about what the definition of a volt, an amp, and a watt is. And we know volt is the potential difference of a circuit. We talked about that when we talked about the size of a water pipe and the fact that the different sizes of a pipe don't mean more water go through it, gives the potential for more water to go through it, right? The amp is the current or the flow of the electricity. How strong is the flow going through it? And so then we end up with watts, which is our total power, which is found by finding volts times amps equals watts. Okay. Then we talked about different problems with power and the difference between blackouts and brownouts and surges and spikes and what kind of things we have available to us to condition those for those things. So we know that surge suppressors handle spikes, power conditioners handle brownouts, and uninterruptible power supplies or UPSs handle blackouts as well. And the way those work is that a surge suppressor basically shunts off or stops all the flow of electricity once it hits some clamping voltage, and it's measured by how high of a voltage you can take or how much energy they can absorb. It's a very inexpensive way to protect your equipment. Whereas power conditioners, they also do spikes, but then they add the ability to condition power for brownouts or drops in power. And then our uninterruptible power supplies do those two things and add the ability to back up for complete AC electrical failure. The smart ups is just an ups that can hook up to a computer, monitors the load, and can shut down your computer for you as well. We also talked about static electricity, the kind of control devices that you can have to protect your equipment while you're working on it from static electricity problems. And you know that you're going to get this question on the test. And the reason is because there's a point where we wouldn't even know that we had a static charge, and if we felt it and didn't hear it, and if we saw it, what are those numbers? And you should know those numbers at this point. And if you don't, make sure they're in your notes. 3,000 volts to feel it, 6,000 volts to hear it, and 8,000 volts to see a static electric discharge. And we talked about those things that are available to you to help protect your equipment from static electricity. We talked about EMI and what EMI does and how it can change a signal and ruin a signal, make the video on the projector. We talked about that looking badly and how running electrical cables too close to each other can cause problems. We talked about AC, DC power, and the biggest thing in this chapter really to come out from is how do I decide on the power supply that I'm looking at buying. And so if I can't decide on a power supply, which is one of the first components we need to look at, we need to be able to. And so we got into looking at power supplies and available wattages and available plugs, and how can I decide which ones are good ones and what plugs do I need based on the system that I'm looking at. We did the laundry list method, which is where I'm going to give you this and you're going to go through and say, yes, it's got a motherboard and it's got a quad-core CPU and it's got a gamer video card and it's got 2 sticks of RAM and it's got an optical drive and it's got 2 hard drives. And you add all those things together to remember to find your calculated number, and then you round up to the next 50 or the nearest 50 to get what I would call your minimum, and then you would add 50 to get your recommended. And hopefully you guys all remember how to do that. And use the power supply wattage calculator, and you'll be using the simple one during the test to calculate the power for at least one PC as well. Then we talked about how to detect and correct power supply problems. If we add new things to our computer and we don't upgrade our power supply, things can possibly not work. So if we calculate our wattage and realize that our power supply is too small, we may need to upgrade our power supply and get a larger wattage power supply to get all of our stuff to work, or we won't have everything running at the same time. I had this exact problem with my computer at home. I had a solid state drive that kept dropping offline. I thought it was the drive and it was the power supply. So we're going to use those wattage calculators just for that, to make sure that we've got the right power supply for our computer. We have some basic troubleshooting things that we talked about during the power supply section. How do we know if our computer is working, and how we can tell if the power supply is going out? Doesn't say it on this slide, but we talked about how we can put our hand over the back of the PC case and see if there's air flowing out of the power supply. If there is not air flowing out of the power supply, it's probably overheating and shutting down. And if there's no lights anywhere, it could be the power supply has gone out. It could be that things are disconnected, but generally it's one of the first things to go when it comes up. And really, troubleshooting is chapter 16. So some things that we can realize in power supply though: do we have odors? Have we checked all the power? Have we checked all the connections? Have we checked all the switches? Surge protectors, UPSs, circuit breakers, wall outlet. The fan's not on, we turn the power on, we need to make sure that all the connectors are good, and we have to check that outlet and any power strips to make sure those aren't turned off as we're looking to see if it's getting power inside the case. We can look to see whether the remote switch works or not. We've broken down PCs and put PCs together. We haven't done it for a while. We're probably going to do that actually on Monday. I know I said that you guys would have time to study for your final exams as well, but if people want to, we're going to do some PC breakdowns and rebuilds on Monday to practice that. The other thing is, we obviously have those power supply testers. We can use those as well to make sure that our power supply is getting good voltage and determine if that's what's wrong with our PC. So we can look and see if it's a non-functional fan, and if it's a non-functional fan, that might be a symptom of a different problem, like it's all gunked up inside. Okay. We also can have overheating, and if it hangs after it's run for a while, or there's poor airflow through our case, if it's all gunked up so air can't get through our case, we can have overheating on our PC. And if it gets below that 100 or above that 185 degrees, and you realize it's any component can fail, and the CPU can turn off the computer, the motherboard can turn off the computer, anything in there that's getting too hot and not getting the airflow it needs can cause the system to fail. We talked about putting in fans and how the airflow goes out through here, and so this should go out through here as well. The last thing we want is to have a circular pattern of air being pulled back inside our PC. We want a constant flow of air through our PC from the back, or vice versa, depending on where our power supply is mounted inside our computer. And that's what this is really talking about, is making sure it flows whatever direction it's flowing, making sure that it continues to flow that direction throughout our computer. So then we got to motherboards. We talked about chipsets. I've already talked about it once. The chipset determines how information is passed to the CPU. We got our north and we got our south bridge. The motherboard also determines the kind of memory and what number and kinds of expansion slots and what kind of case we can put it in. So the selection of the motherboard and the CPU go hand in hand with determining and deciding what kind of computer that we're going to buy and build when we're looking at computer parts. So when we look at motherboards, we know that this is an ATX motherboard by the overall layout. We also should be able to know right away what kind of CPU we're looking at or what kind of CPU manufacturer we're looking at. We should be able to tell whether we've got how many kinds of memory. I can't tell just from looking at this whether it's DDR3 or DDR4, but I can make a pretty good guess that it's dual channel RAM by the different colors. I can look at the different kind of expansion slots available to me and whether this one might fall into a specific category. And then same thing here with our other CPU manufacturer, realizing that CPU manufacturers are not the same as motherboard manufacturers. I just lost my picture there somehow. We know ATX describes the general layout and shape of our computer, and it's very specific on how holes are lined up. If you don't get the right case for the right motherboard, things aren't going to line up and screw in. We know that the first thing that we're going to put in our motherboard once we decide it is our CPU. And we talked in class as part of chapter 4 is how we rate those CPUs. The three things that all come together for the overall rating of the speed, our overall rating of the CPU is our CPU speed in gigahertz, the total amount of cache, and the total amount of cores. And I'm going to put threads down here too of it, because obviously if it's got 4 cores and hyper-threaded, it's got 8 threads. That's probably going to be faster. When I talk to you both in the chapter 4 test, as you know, and on the final exam, I'm going to ask you which one's faster. I'm asking you to check pass mark, okay? I'm asking you to look at a site, and you know in here we're using pass mark to rate our CPUs, because we can't just look at one of these items to know how fast it is. If I say which one's faster looking at the speed of the processor only, then I'm being a bit of a lazy moron at Walmart, right? I'm saying all I know is the gigahertz. I'm asking you which one's faster, and then I might ask a follow-on question. I'm sorry, which one's faster when I talk about speed only, and then which one is faster overall. I'm talking about pass mark ratings, and I'll say specifically that in the question, just like I did on the chapter 4 exam. We know our CPUs, there's only 2 CPU manufacturers left anymore, and that's AMD and Intel. Intel started, and then we know that AMD got Intel into the manufacturing. We know that Intel is primary with land grid array or LGA sockets. We know that AMD is primary with, there's a picture of LGA sockets, and you should be able to identify them simply from pictures and know that those are going to be Intel. We also know that AMD is primary with PGA sockets, and we should be able to identify those straight off of pictures. The only thing that doesn't fall into that category is the Ryzen Threadripper, which is an LGA type, I'm going to call it type socket because it's really different than anything else. It is an LGA socket, is an AMD, but it's the only one that falls into that category. It's the only one where you're screwing in a processor into the motherboard, and it's ginormous. You can see that here's how big the memory is. From here to here is RAM. It's almost the size of the RAM, and we know from all of our other ones that it's nowhere even close to the size of the memory. I don't have, I guess, a good picture here that shows the memory next to it, but in general, LGA, Intel, PGA, AMD, except for the Ryzen Threadripper series, which we saw lots of examples of the Ryzen Threadripper on our AMD presentations. One thing I did not talk about, which is one of the things we're going to talk about when we get back, which is CPU cooling, and it should have been covered in the CPU section. I don't know how I forgot to talk about CPU cooling, but it goes right along hand in hand with the CPU, is how are you going to keep that processor cool on the system that you put it in, whether it's going to be a big fan system with a copper heatsink like this one, or is it going to be one with pipes? Is it going to be liquid cooled? That is not part of the final exam. I just wanted to mention that we're going to talk about cooling and the different cooling options when we get back. Not included on this final, but I should have talked about it. The chipset, we already said, controls the memory cache, the external buses, the peripherals, and how all that information gets around the motherboard to the CPU. And so the chipset's totally in control. Small amount of processing going on there, but there is processing. But it's how that information gets around the bus or the whole board and back to, in that case, that's where the CPU socket is, back to the CPU. Talked about the north bus route is memory and video only. The south bus route is everything else on the motherboard, connected to the motherboard, talking to the CPU, talks to the south route, so that the memory and the video, which is primary to many things that happen on our computer, if not all, but memory is primary over everything else. But if we're talking about a video intensive thing, video can be just as intensive as memory on some of the higher end video games and video graphical editing programs. So those are on the north, the other ones are all on the south bus route. The motherboard determines what the chipset is on the board, determines the type of CPUs, determines the type of memory, determines the type of expansion cards that we can get on there, the type of case. So our motherboard determines those. Sometimes we work backwards though. That's what we were talking about the other day, and that was the point of that exercise. Sometimes you choose the CPU because you know what you have to have. Then you choose your motherboard that's going to house that CPU. And while you're choosing the motherboard, you make sure that it holds the memory that you want, the expansion card slots that you want, and those kind of things. That's the point of the exercise we just did the other day. We know how to compare CPUs. We know we use Passmark to get an overall rating and see how they are. But all those things that come together are the speed rating in gigahertz. So when I ask you the speed versus the rating, you know what I'm talking about. And that's the most common way to compare them. Number of cores and threads, because we need to know both of those things, and the amount of memory, whether it's L1, L2, or L3 cache on our PC. And we talked about the difference that if this one was a quad core, if there's L1, which there does not have to be, by the way, there's L1 per core, there's L2 per core, and there's L3 that's shared. And it doesn't have to have all of those different kinds of cache. It has to have some of them. Ones that miss one or miss another may be an indication of why they're slower or faster. If it's got tons of L2 and L3 versus one that's got L1 and L2, you may not see the same speed. We talked about what a bottleneck was and the fact that if our CPU is a 4 gigahertz processor and our motherboard takes 2000 megahertz RAM, we know that the speed of the motherboard is half the speed of the CPU, because 2000 megahertz equals 2 gigahertz. And so our speed of the motherboard is half the speed of the CPU. So if there's a bottleneck on our computer, it could be because there's too much of a mismatch between motherboard speeds and CPU speeds. So as we're purchasing, we want to try to, if we don't want to spend all of our money here and none of our money here, because then our motherboard can slow down what our CPU is capable of. We want to try to make sure we get a nice mesh between the two so that we get a really good performance out of both of those. Okay, that's it for the things I wanted to talk about. I wanted to go back and make sure I hit everything on the self-assessment, that I didn't skip anything. We talked about the motherboard chipset. We talked, I don't think that was the case. 2018 students, there we go. We talked about what BIOS RAM is. We talked about CMOS. Can you use BIOS to configure your PC? That's where we went in hitting F2. We set our boot order. The fact whether you can or cannot is, I want you to say yes, obviously, this question, but there's no way for me to test you on it in the test. Can you explain how the OS uses BIOS information? We went over that. Can we explain what a device driver is? We went over that. Can we explain the boot sequence steps? We didn't go over all of that. We've done so many exercises in that. Only one person said they couldn't. Make sure you go back through that information if you're that one person. Can you explain how CMOS ROM or ROM BIOS finds the OS? Basically, BIOS program in ROM finds the OS off of the boot order that we stored in CMOS RAM. We talked about volts, amps, and watts and what they are. AC versus DC, alternating current from the wall versus direct current, which is in our PC. Didn't talk about this one, hot, neutral, ground. Remember that on our wall plug, we have, I can't draw on there, we have 3 different plugs on there. We have a large one, we have a smaller one, and then we have our little ground one in the bottom. And it comes in through hot, and it goes through our electrical devices and goes out through ground, and I'm sorry, through the neutral. The ground is there in case there's any extraneous voltage that needs to be shunted somewhere. That's what it's for, and that's why good electrical devices have to have a ground. And we talked about how the ups won't work right without a ground. Well, nothing will be able to handle a spike without a ground outlet on there as well. We talked about static electricity, what it is, how to avoid it by grounding ourselves. Remember, we always are unplugged. We always touch the metal case or the power supply first. We hold down our power button before putting our hands inside of a PC to make sure everything's grounded. I could talk about this one again. The voltages that come out of a PC, I didn't go over that again, so I'll go ahead and grab a picture of a power supply real fast and throw it out here. I think I got a better one. Yeah, I'll just go ahead and use this one anyway. Okay, so first of all, we know that there are 3 voltages coming out. We've got 3.3 volts, we've got 5 volts, and we've got 12 volts on our computer. That's why this is a bad picture. Thought I had a better one. Let's see if I can find a better power supply picture with the plugs all out for me. Good enough. Ah, that's a great one. Let's see if I can. Okay, here's even a better one. Oop. Let's see if I can move this one up here. Not great, but not terrible. So as I look at this one right here, my P1 plug's up here, by the way. You can't see that. Right, there's my P1 plug. My P1 plug is my largest plug, and it's my lowest voltage. It's 3.3 volts. Okay, and then what I talked about is really you can consider all the rest of the plugs that plug in, other than the floppy cable, which I don't even see one. There's one right there. Okay, so there's my 1.5 volt, and all the rest of the plugs coming out of there are 12 volts. Okay, so they're higher voltage because they're for things that move. Okay, I'm plugging these into hard drives and CD-ROMs and fans. This one's plugging in directly in the motherboard to run the CPU and the higher wattage requirements of today's CPUs. We've got our P4 plugs plugged in right in there. We've got plugs for our, actually that's that one. This one is, looks like a 6-plug PCI plug for a video card, all 12 volts. So we've got 3.3, 5, and 12 volts coming out. Biggest plug, the P1 plug's 3.3, and almost all the other ones are 12, other than the floppy drive connector, which was a 5-volt connector. Okay, so that's that one. I can calculate an extra wattage. That one's just a laundry list item. Just need to go through the components and remember the calculated versus minimum versus recommended, where we're getting the calculated, whether it's off the power supply calculator or after adding our laundry list together, rounding it up to the next 50 to get our minimum, and then added 50 more to get our recommended. And realizing that I can always go larger. It's more efficient if I do. I just want to stay away from those minimum numbers. I can replace, install a power supply. We've done that so many times, I'm not sure how anyone said no on that one. We pull that out, take out the 4 screws, and we put in a different power supply. We'll do that again and again this year. Obviously, I can't test you on that on a written exam anyway. I can explain the speeds of a motherboard relative to the CPU, and that's what I was talking about when I was talking about bottlenecking. What is the relative speed? I look at my CPU speed, it's 3.6 gigahertz on a given system, and when I talk about relative, that's where I'm talking about how bad the bottlenecking is. What in the world? So if I had, in this case, a 3.6 gigahertz, and I should be able to change those over to the same thing, and I know that, for instance, my motherboard is, I've got in there 1800 megahertz RAM. So what's the relative difference? 1800 megahertz is the same as saying 1.8 gigahertz, because I just divided by 1,000, right? Move the decimal place 3 over. So in this case, my relative difference is the CPU is 2 times faster. Or conversely, the memory is 2 times slower, and I would like it to be a less than 2 differential if I can. I'm not going to ever get it to 1. You're not going to get, well, that's not necessarily true. There is DDR4 that's up to 4,000, and you probably could get the exact same speed on the thing today if you wanted to. I can use BIOS of various systems to configure CMOS. We've done that a number of times. Can't really test you on that. And that is it for the items that were on the self-assessment and a very fast review of the entire semester. You have the rest of this class to look over stuff, and also to email me if you have any questions on anything you didn't understand. Again, OpenNote, Open Moodle. All the tests will obviously be hidden during the exam, but you'll be able to access any of the other information that I have on there as well. And that is it for today. Let's see, F6.